Yeah, go
Hello,
on.
can you hear me?
Yes.
My name is Juliet Onyango. I'm here because I want to learn.
Yeah, thank you, Juliet. Let me
Yeah.
go to another one. Miri. Kelvin Miri, kindly unmute your mic and just introduce yourself and one key expectation that you have this session.
Okay, thank you. Good evening, everyone. My name is Kelvin. In this session, I expect to learn more about data science and how this field we can utilize the skills in data science, especially in especially in decision making. So, thank you.
Thank you, Kelvin. Without much further ado, let me just again welcome everyone and thank you for joining us today as we dive into this fascinating world of data. And we know in this time when data has become a critical asset in all aspects and in all sectors, and the ability now to analyze and interpret it effectively is a game changer. And I believe today's session will cover how data is not just about numbers and models, but about extracting insights and also how that can empower us to make smart decisions, solve complex problems, and also drive meaningful change. And we hope that this webinar will inspire you with fresh perspectives on on how data can be leveraged to achieve impactful outcomes in any industry. And whether you're experienced data professional or someone that is exploring this field for the first time, I believe there is something here for you. And our speaker today will take us through the fundamental concepts and also industry applications of data science. And I believe by the end of it, as we make this session more engaging, we are open now to answer any question that everyone might be having. We are also open now to encourage everyone and also work with you in case you want to venture into this field. We are open now to work with you in the journey of data science. And just now to without now wasting time, because we just have a one hour for this session, I'll just want to take this opportunity now to introduce the key speaker who will be taking us through this session. And today we are just honored to have Teresia Muiruri with us, who will be taking us through this session. She's a seasoned technology data and analytics professional from PwC in UK. And she has a focus on leveraging data-driven insights to drive business success. And Teresia brings a wealth of experience and practical knowledge to our discussion tonight. And she is currently advancing expertise through masters in analytics from Georgia Institute of Technology. And I believe she'll talk more about it. And her journey done in data science and in business analysis spans roles at prestigious firms like Deloitte and also Predictive Analytics Lab, where she's excelled as a senior business analyst and a data science trainer. So allow me just to take this opportunity to welcome Teresia. Teresia, kindly just pick it up. I know that your profile is very huge. I just mentioned but a few. So you'll just pick it up there and also take us through this session. Welcome very much.
Thank you so much. Can you hear me?
Yes, we can.
Okay, great. Thank you so much for the introduction, Joel. So as Joel mentioned, I won't repeat what he said, but basically, I'm a data professional working at PwC UK. I work in the London office, and I started my career now about 5 years ago. I started my career in PwC Kenya, and then I went to Deloitte Kenya for a few months, and then I moved to the PwC UK firm 2 years ago. And on top of that, I used to be a trainer at Predictive Analytics Lab. But before I became a trainer, I used to be a student. So I was actually in cohort one. I was student number 2 at Predictive Analytics Lab in 2019 February. In addition to my work, I'm currently doing a master's degree in analytics, computational science at Georgia Tech. And today I'm excited really to talk to you about data science and just to have a chat. So feel free to unmute yourself to ask a question in the chat. And I hope by the end of this session, you will have gained a bit of insight on the world of data science if you're new, and if you're a seasoned data scientist or you're in the field already, it will, remind you of the basics of this data science world. So without further ado, I will share my screen. Let me know. Let me know if you can see my screen. Am I sharing it? No, wait a minute. Can you see my screen? Let me know if you're able to see my screen before I move on.
Yes.
Okay, great. Thank you. So if you have any question, I will keep going back and forth on the tabs. So feel free to ask your question on the chat or unmute yourself and ask. So treat this as a very interactive session. So I will cover 1, 2, 3, 4, 5 key areas today. So I will introduce what data science is. You probably know what it is, but we'll just have a discussion around that. And on that topic, we will also look at the data science life cycle to just help us understand what is this data science, what does it involve? So sort of removing the black box when it comes to defining data science. And we will briefly look at application across different industries on a high level. We will look at the key skills and tools that we need to succeed in this area of data science. And then for beginners, how do we get started? I know there's a plethora of information online on data tools, and right now information is readily available, but what is a good way or a suggestion of how to start? And then the other one is the future of data science. What are the trends? What are opportunities and challenges we are seeing in data science? I will start by defining data science as a field, an interdisciplinary field that uses data to solve real-world problems. And if you look to my right, there is these key pillars of data science. So these are what professionals now consider as, these are the pillars that support or contribute to saying that data science. The key one that is a major one is domain knowledge. We mentioned that data science solves problem for real world scenarios. And one thing you need to know is a data scientist in healthcare is not the same as a data scientist in finance, for example. They are the same in terms of the tools they use, but a data scientist in healthcare has a sort of domain knowledge in that area that data scientist in the finance sector probably doesn't have. And it is very important because most of us here probably on this call maybe already have started other careers in different areas, and you might wonder, so where is my place in data science? I wasn't trained as a data scientist from the word go. I didn't pursue computer science. I didn't pursue a technical course. But just remember that whatever domain you are in, whether it is technical or not, there's a possibility and there's a chance for you to apply data science. The other key pillar is mathematics skills. As you know, or you might not know, data science is driven by math and statistics. So it is core to being a data scientist. The other one is computer science, and this is basically the study of algorithms, optimizing algorithms. And you don't necessarily need to have a 4-year computer science degree, really, but you just need to understand the key basics of computer science for you to say that you're a good data scientist. The other one is communication skills. It is data science itself, it's a science, but behind that, you need to be able to tell a story with data or the insight that you have gotten. And communication skill is one of the key skill or requirement for you to say that you're a good data scientist. And the good news is that in every area of work or business that you're doing, communication skill is a transferable skill. So that means if, for example, right now you think you have domain knowledge, you know a bit of math, and you have communication skills, you probably need to brush up on your computer science knowledge, and you can get started within data science. So briefly, why is it important? Like, why do we have to talk about data science all the time? I think one of the key importance of data is you're able to convert raw data information that has been gathered from a myriad of sources into insights that are beneficial to the business. It enables you to do predictive analytics, predicting the future. It also helps us to understand our customers better. With a lot of data, for example, you're running a marketing company and you have a lot of data on different customer behaviors. With a lot of that data, you're able to, generate insights and understand your customer better. Improved accuracy. I mean, this is in relation to you have data that is helping you to make decisions. And that means instead of relying on intuition, maybe your past experience, which might be biased, you're able to have accurate results, more accurate results as compared to if you're not relying on data to make your decisions. And lastly, evidence-based strategy. So when most companies are making their strategy, depending on maybe it's a marketing strategy, a supply chain strategy, whatever strategy, if you leverage the data that is present or you got it from different sources, you're able to sort of create a strategy that is not, a wish list. Doesn't look like a wish list because you have data and it is evidence-based. Next, I want us to focus on this data science life cycle. And this is a typical end-to-end process of how a typical data science project would look like. So probably you might ask yourself, so if I'm in a data science project, what do I do? Am I the only data scientist in the organization? As you look through this diagram, you can see that, first of all, different people are involved in this process. So you're not the only person getting involved. And there are very many steps and processes in here. And that's why you need those different kind of skill sets to understand or to plug into the data science life cycle. So let's start by the first step here in this cycle. And the first one is problem identification. So a problem identification is the basis of everything you're doing. So anything you do, even in the business world, whether with data science or not, you have to identify a problem that you're trying to solve. Let's assume for a case of a bank or a credit card company, their problem is fraud. So they have a lot of reported fraud within the bank or the financial institution, and they need to create predictive, for example, a predictive model to solve this or to predict fraudulent transactions, for example. So we'll use that example to run through this. So after identifying the problem you have, you need to have a business understanding. So the thing about data science problems or any problem, if it doesn't make sense to the business, you might have a problem, but you have to look at your problem from a lens of the business. For example, business understanding in the case of fraud would mean what is considered a fraudulent transaction. So probably in a bank that operates in the UK, for example, a fraudulent transaction is a transaction that comes from one of the war-ridden countries. But in a different transaction, in a different scenario for the same bank, maybe in a different location, a a transaction coming from X location does not necessarily mean it's fraudulent. So by breaking down the problem and looking at the problem from the lens of the business that you're solving the problem for is an important step in the data science life cycle. After identifying or defining your problem in the lens of the business, the next step is, where do we get the data? So does this data sit in different systems? For example, in a banking situation, customer data sits across different systems, right from the time they start interacting with the bank. Uh, Data is also generated from aggregations within transformation within the system. So this is a step where you sit and ask yourself if you have the data you need to do your analysis internally, and if you don't have the data, there you can leverage on data from outside. So there are companies like Refinitiv, Bloomberg, for example, they do sell data. So this is why you decide where do we get the data? How do we extract the data from these various sources, transform the data in a way that we want to use it, and then, for example, you can load the data in a warehouse. After that, there is the understanding data, and this is the exploratory data analysis. So when all this data comes, it has all sorts of pointers. You have maybe a data with 10,000 there are 10,000 rows and maybe 15 columns, but probably you need only 2 columns for your prediction. So this is a key step in the data science life cycle, and this is where you explore the data. And when doing the exploration, you do need to have data visualization. So if you're, for example, looking at transactional data from different customers, you might want to maybe aggregate, customers by regions, by locations, by age, by amount. So you just look at the data and then you look at the correlation of the different data points. And so this is a step that is important, because the next step after exploratory data engineering is feature engineering. So after you have identified your most important data or features, you might want to create new features or leverage on the existing features, because these are the features that you now feed into your model. And this is where you decide the model creation, training, validation. You choose the model that you want, that is best suited for your problem. So you might find that, maybe it's a classification, so you might want to use logistic regression. If it's a different kind of problem, you can do time series. You can also do linear regression depending on the data you have. Then we now move to model. You deploy your model into production after you have done your model creation, training, validation. After you deploy model into production, we need to ensure that any changes in the data from ETL, maybe the data changed at some point. This is the data drift analysis. So if the distribution of the data fundamentally changes, you need to go back in between the data drift analysis step and the model training stroke validation. So it is very important to make sure that the whole data pipeline is being monitored for any drift in data. And then also have model monitoring. And this is why you monitor how the model is performing. How is it performing on newly introduced data? Does the performance of this model change as new data is being introduced? And therefore, this is an ongoing sort of continuous monitoring of the model that is in production. Then after doing the model drift analysis, we go to reporting. So after all is said and done, our results are mostly consumed in dashboards, reports, and scores. And this is because when you're presenting your results to senior management within the organization, they really don't want to, they probably would want to know, but they really don't care about the details of all this process. They just want to see numbers, dashboards, reports, scores of how your model operated. And then that is the end-to-end process of a typical data science life cycle. So there are people, probably there are companies with shorter cycles, there are other companies with longer cycles, and then there are other companies with maybe a team for doing the research, they understand the problem. There's another team for data acquisition. There's another team of data scientists for understanding the data and engineering, and probably there's another team for model monitoring in production. So it really depends on the kind of organization and the kind of resources they have and objectives as well. So that gives us, a basis of what is all this world of data science, what does it involve, and what, where can I come in as a data scientist? The other, let me just check whether there are questions in the chat. Okay. The other discussion that I want us to gloss through today is application across industries. And I just put this image here, knowing that, one, this is not the exhaustive list of industry that there are for data science to be applied. And two, I know people have probably, from wherever you see it, if you have worked somewhere, you probably have identified, use cases, or this is how I can use my data. This is how data science can be applied. So I'll just go through, this maybe the common use cases of data science across industries. So in e-commerce, this is things like the Amazons, the eBays, and they use that a lot. So they use the data that they collect from us to identify customers, recommendation of products, and analyzing reviews. That's why when you go to Amazon, like you see recommendation of customers who bought this also bought this. So that sort of profiling is as a result of analytics that have been done on people who have a similar profile to you that purchased a certain item, and they also purchased, another thing. That's why you get the recommendation, because you fit into the profile. Sorry, is there a question? Okay, cool. The other one is in manufacturing. So this is like, for example, automobile or in a manufacturing facility. They mostly use data science in anomaly detection. So for example, a machine or a certain machine within the workflow fails at a certain time, or it fails after producing X number of units. So they might collect that data continuously for a long period of time, and they will know after X amount of times this machine is likely to fail. They also do maintenance scheduling. So instead of going through, I know they have a schedule for maintaining systems, but they might want to optimize how they do that by creating a monitoring system that highlights these are the parts that need maintenance more than other parts. Yeah. The other one is in banking, and this is banking and financial services mostly. Fraud detection, as I have explained. So they use a lot of that in fraud detection, predicting what kind of transactions are likely to be fraudulent or not. Credit risk modeling, this is maybe for loans, knowing who is likely to repay a loan or not. And customer lifetime value, so as a customer of a bank, they are able to predict your lifetime value for the time you've stayed in the bank. The other use case for data science is in the healthcare field, and we have seen this come up a lot lately. So medical image analysis, bioinformatics, discovering new drugs based on information about maybe patient history, your drug usage in the past, and of course, virtual assistants. The other use case is in transport, the self-driving cars, car monitoring system, and enhancing safety for passengers by maybe looking at which parts of the car are most likely to be damaged in the case of an accident, and ensuring that they enhance those parts of the car as opposed to what they thought was more important. The other one is closely related to banking, is also in finance, customer segmentation, knowing what customers to put in what buckets based on maybe classification, decision making, algorithmic trading, and of course, risk analytics. So I know there are 1,001 applications across different industries, but this is just to give you a gist of how much data science is applicable in different industries. So let's move on to skills and technology and the tools that we need for data science. So as we saw earlier here, we said that the fundamental pillars of data science are domain knowledge, mathematics skills, computer science, and communication skills. So technical skills, what do you need to succeed as a data scientist? What kind of skills do you need? At the very, very minimum, you need to be knowing a programming language. And by programming language, you can use whichever you want. You can do Python, R, those are the most common ones. And you need to know these programming languages. According to my experience, you need to know the basics first. Because I've noted that, for example, currently, I said I'm doing my master's, and there's some challenges that they're like, oh, you need to implement a certain end-to-end pipeline. And I found myself struggling a lot with concepts for the areas that I have become rusty. And I've always had to go back to the basics. So I think that is something I really wanted to highlight in today's session, because sometimes as you continue being advanced, there are very many, technologies, libraries that are coming up, but you have to remember that always go back to the basics. Always go back to the basics when you're not able, when you feel like you're stuck. And this is the case for most people who start, you start learning a programming language, or you start learning a certain tool, and then you do one, you do a code along project, you finish it, and then after a few months you feel stuck, you feel like you can't advance, or you're presented with with maybe you're doing some certain coding thing online and you're stuck. Just remember, go back to the basics. You see those basics of bitwise operators, how do you define this, how do you define a function? So always going back to the basics really helps. No matter, I have people, my friends who are very advanced, who are ML engineers, and they always remind me, whenever you're stuck on something, whenever you can't understand something, just know it's because you didn't understand the basics. And every time I have gone back to understand the basics, without the intimidation of all these new technologies, it always helps. So programming skills, statistics and probability, you have to know data manipulation and cleaning. You need to know machine learning algorithms. You definitely need to be good at data visualization. And data visualization, I insist, is because that's the only way to communicate what you have done. That's the main way to communicate the output of what you've done. Last but not least, you need to understand big data technologies. This is because there's a lot of data being generated all the time. And most of the time, this data is stored in, Hadoop, Spark. You need to understand at least, and as well as cloud technologies. The other skills that you need to be good at for you to be considered or to consider yourself a good data scientist is communication. As I said, you're presenting your results to people who are not technical. So you need to be good at, conveying whatever it is that you have done. You might have done a very good job, but if you're not able to articulate that to the people the stakeholders who matter, or the decision makers, then I think there's a problem in, how you consider yourself as a data scientist. The other skill that you need to have is problem solving skills. This is because, data science is like programming, and programming is basically solving problem using code. So you need to be good at your programming skills. Problem solving skills. The other one, as I said earlier, the domain knowledge and the business acumen. We are not solving data science problems in a vacuum. We are solving data science problems in some context, and most of the context is a business. So you need to understand the domain for which you're solving the problem all the time. And lastly, curiosity. There are new technologies all the time, every day, and it is up to you to keep yourself up to date, to continuously learn. And curiosity is one of the skills that will get you going, despite new things coming up. So we are actually almost done. This is so how to get started. So I created this sort of, it looks like a timeline, but I wouldn't say you follow these steps one by one. But I think one key thing, as I said earlier, you build a strong foundation. I can't insist on how important it is for you to build a strong foundation, because I've seen people, and when I was starting off my career, and at some point I also got into that loop where I go online, I do a course on Udemy, for example. I finish the course, I do the project, and I post the project on GitHub. And at that point in time, I feel like I know everything there is to know about data science. I've done a project, I've done it, end to end, but I forget that I did this project this well because I looked at someone else doing it. But I think the question that I need to ask yourself is, if I was to do this without looking at this person doing it, how would I approach it? And this is a challenge to yourself. So I think after you do your tutorials, don't get stuck in the tutorials. What do they call it? I can't remember the name. Yeah, death by tutorials. When you do a tutorial, you understand the basics. I think it is important for you to challenge yourself by building something, no matter how small it is, from ground up. So put yourself, even if you're not working on anything that is being looked at by anyone else, put yourself in the shoes of, maybe you're being hired as a data scientist or a data analytics associate for an organization and write down the problem like you would write it if you're solving it for a business. And it is going back to this data science lifecycle here. Assume this is what you've been presented with. So write your problem or whatever you're trying to solve in this way and try and challenge yourself to create something out of nothing. And that is how you build a strong foundation. After you build your foundation, as you do this tiny project, these pet projects, you can showcase your projects on GitHub. You can participate in Kaggle competitions. So for those who don't know, Kaggle is a sort of a machine learning thing that was created by Google. So they post a lot of data sets and competitions. So even if you don't have a real life, use case, whatever you are, for you to practice, Kaggle can be good at that. And it's very encouraging because when you ask a question in that platform, people are always responding. You can see what other people have done. So people have their code out there. So it's not like you're fully stuck, like you don't know what to do. So you can get guidance from online. And once you develop a portfolio, I feel like you're more confident, one, that I not only have the skills, but I can showcase what I can do with the skills I have. And to me, it feels like we have a lot of people online, they're like, oh, I'm a data scientist, I can do this, I have done this, I have done this, or I have done this course, I have done this course. But when you go down to the lower level and, like, show me what you've done, what can you create? They have nothing to show for it. So I think this is a kind of profession where it has to be evidence based. If you get what I'm saying, you have to don't just tell. I mean, you have to show what you're saying. The other thing you need to do that is important is networking. So we have LinkedIn, we have conferences, we have a lot of tech meetups. And then if you're on this point of networking, if, for example, you're working in an organization and you're probably not in the data team, for instance, or there's a data team in your organization, and you're just interested in, knowing how they operate, I suggest that you network internally, ask, the manager of whatever, or even a team member of the team that you want to move to, how do they do things? And I think by starting those conversations, you're able to put yourself in a place where, one, people know what you're interested in, and two, you are able to know if this is an opportunity for you or not. And then finally, I think breaking into this field, obviously you need to apply for jobs, or you can even have your own startup if that is what you want to do. Prepare your resume, apply for roles, subscribe to they're like companies that send you like interview questions on a weekly basis or on a daily basis. Just practice, do mock interviews with your friends or with people you find online, and then get the feedback and repeat. And one thing I would like to say also, this, I probably should have presented this as a cycle, because it's not like you build a strong foundation and you never go back to it. You're always going back to the basics. You're always going back to learning the new technologies or anything new that comes up. One thing that I want to say in this, as I discuss this before I forget, I know we have ChatGPT, and right now ChatGPT, you can literally ask it any question, regardless of how complex it is. You just need to give it a bit of background and it will generate for you the code for whatever you want to do. And in as much as it is very tempting to do that, I honestly think it takes away your opportunity to understand things from ground up. And my opinion about ChatGPT is it should just help you to understand things better. So probably like don't take away that chance for you to understand complex things by using ChatGPT. So for instance, maybe you're formulating a pseudocode for just randomly cleaning a certain data set. I would suggest you start by doing it yourself. Write the code, go to Google, go to normal Google, go to Stack Overflow, ask your questions there. And then once you write the code and it works, you can ask ChatGPT to now explain to you the code. Instead of asking ChatGPT the question from the word go, try to struggle with the logic. And then once you get it and you think you've gotten it, but you need more understanding, take it to ChatGPT to explain to you. You can even say, explain to me like a 5-year-old, So in a way that you can, you yourself can also explain it to someone else. Future of data science. So I don't know if this is future, but I wanted to highlight these 3 key areas when it comes to the data science future. And one is trends in data science. What opportunities and challenges do we have in this area? And in as much as we said data science itself, it's an interdisciplinary field, but on top of it being an interdisciplinary field, we are also seeing it interact with, other, areas within the emerging technology space. Let's talk about ethics and privacy. So as you might all know, the past maybe decade, a lot of data, massive amount of data are being generated and are being domiciled across, countries, data centers residing in different countries. And at this point, organizations are very key on where their data is being stored. Is When I say stored, I mean, where is the data center? Where is that Microsoft data center located? And we've heard of regulations such as GDPR, they apply to EU countries. We also have like a country like Switzerland, it has more strict data regulation and data regulations. And within this field of data science, there are people who are choosing to focus on ethics and privacy, data protection. How is the data being used? Is it being used for the reasons that you said it's being used for? How long is this data being used for? Do you have consent to even store data from your customers? Yeah. So this is a key trending topic in data science. The other one is automation, and by automation I mean instead of repeating some manual tasks that you used to do, you can set up for example, there is the what is it called? I can't remember the technology for automating repetitive tasks by using maybe previous data that has been stored before. The other one is augmented analytics. Another trend that might not be here, it is under interdisciplinary connection, is generative AI. And generative AI is basically leveraging, building large language models and using that data. And there's this whole concept of prompt engineering. I don't want to talk about it here because it's not part of this discussion. It's something you can also learn about. Yeah. So it's basically, if you drew a diagram of there's data science, within there's machine learning, and on top of that, there's artificial intelligence. And then on top of artificial intelligence, there's a generative artificial intelligence. And that's where you learn about things like prompt engineering. So those are quite advanced, trends. And they are happening and businesses are adopting that. The other thing I wanted to talk about is opportunities and challenges. And I think data democratization is an opportunity. But before I talk about data democratization, I want to talk about data quality and accessibility. So till to date, organizations, and this has been my experience from the project I've worked with in my clients' environments, data is still not being treated, in an equal way across the organization. And by this, I mean different business units still operate like separate entities in a way that they belong to the same organization, but they are siloed and they don't communicate to each other. And that means, for example, if there's a center of excellence that is that's the data team, for example, they don't even have a means of getting data from these different business units in a consistent way, in a reliable way. And the other one is data quality. Garbage in, garbage out. Your model is as good as the data that you feed it. And data quality is a key challenge, and it continues to be a key challenge for most organizations. And this is because I feel like by the time these systems were being put in place, they didn't consider or they didn't imagine the amount of data that would come in, one. And therefore, you have different data sets domiciled in different systems that they don't even communicate with each other. There's no consistent way to do data quality checks. There are not enough controls for data quality. And that is a key challenge and also an opportunity for people within the data science world. So data democratization is a solution or an opportunity. This is where we see that now data is now being readily available, not necessarily to people with only the technical skills. So you find that maybe there are some end user friendly tools that are being developed. Someone can pick up the tool and can put their data and visualize. For example, things like Power BI, Tableau, the less technical tools are now readily available within organizations, to a point that you don't necessarily need to be a technical person for you to access them. So it's the way like Excel now. You can't say that you're a Excel. I mean, you can say you're an Excel guru, but everyone, it was democratized in a way that it's a de facto user application that is needed by everyone. I think the other challenge, which is also an opportunity, there's still a skill gap and talent shortage within the data science world. And I say this because data science is a very complex field, as you have seen, and you need to constantly keep updating yourself and upskilling yourself. So if you're looking for something that is a bit easy, a bit chilled, well, I don't think this is a field that you can say you want to be chilled for a few months, because once you're out a few months without practicing, you come back, new things have come up, you need to upskill. So I think there's still a skills gap and a talent shortage. And I think the solution to this is go back to the basics, understand the basics, because all the time new technologies are coming up. But when you strip all the layers, you go back to the basics of programming, the basics of math, the basics of statistics, and get your domain knowledge up to the good level. Then there's an interdisciplinary connections. We talked about generative AI. We talked about IoT. IoT is basically, something like sensor data. So it's all about, we are getting data from hardware. Then we are using now this data to predict things about the future. We have blockchain. Everyone is talking about blockchain. We have cryptocurrency. This is all about generating data. And by building data science as a layer and leveraging this data science lifecycle, we can say that in whatever area you can sit down and think of, you can find a use case for data science in there. So we have finished 15 minutes before our time, and I will open up the floor for questions, comments, suggestions, or anything anyone might want to share. Oh, I see there's a chat. Okay, so someone has asked a question, Aleo. Can there be a niche of talent who just are great at cleaning data, are great at cleaning data? Well, that's a good question. But I feel like if you're good at data cleaning, you also need to be good at visualizing the data. You also need to be good at communication, So I think there are people who who specialize. They're like data quality managers in an organization, but there is much more to that than just knowing how to clean data. For example, if you're working in a bank and you're a data quality manager, you need to understand things like data controls, the different regulations that require your data to be in good quality. Yeah, so there's a niche for that, but not directly, as you put it. Like I've never seen someone put a post and say, oh, I'm a data cleaning, specialist. You probably might want to even give yourself a fancy name like data quality manager or something. Lydia, do you offer classes? Yes, predictive analytics lab runs cohorts, and probably you might want to reach up to Joel. He's the one on the predictive analytics thingy here. He might give you more insights on that. Yes, predictive analytics lab is actually a school that offers training for data science. Eric has a question. We have discussed how crucial data science is in fields like finance, banking. What role does data science play in the dynamic industry of communication and media? That's a very good question. So just thinking out loud, and anyone in the conversation here can unmute themselves and talk. So in the media industry, maybe media and film, what comes to mind is probably there's a music producer somewhere there's a film producer somewhere that needs ideas on how to create a film from a storyline that is collected from different movies that have been shot in the past maybe 30 years, for example. I think you can leverage that to create a new sort of storyline or script from that. And from an analysis perspective and looking at our data science life cycle, I think people use a lot of these tools to the data analytics and stroke data science tools to look at, for example, what story is selling most, what film, is selling in the best way this month. So this exploratory data analysis phase, and at some point you don't even have to go to the predictive side of things. You can always stop at the exploratory and communicate your results. So I don't know much about the communication industry and media per se, but those are my 2 cents on how that can be used. There's a question from Victor. How can we apply to overcome unemployment status through self-employment? Please consider first job we can have from the data science of employment. Okay, that's a good question. First of all, I think, in my opinion, if you're unemployed, for example, they are very first thing. I've seen people participate on Kaggle competitions, and some competitions are there's a reward, there's a financial reward because it's a company that puts out their a problem out there and people solve it and they're paid. I also have seen other like online jobs, like maybe there are websites that have remote roles. You can probably not exactly as a data scientist, but you can do like basic data cleaning jobs, data visualization, or just analysis of data for different companies. You can start there. And I've also seen people who start this career of as maybe software engineers, and then after some time you've done your software engineering, you branch out. There are people who start their roles as data business analysts, so they do collection of requirements, or then with time they grow into their roles as data scientists. Victor, which machine learning model is different to recommend across different media channels? So the machine learning models that you choose are, specific to the problem that you're trying to solve. But, for example, when you look at classification, we have classification models. We have regression. There's linear regression, logistic regression. So I would say it depends on the kind of problem that you have. But fundamentally, you need to go back to there's some advanced models like LTSM, XGBoost. Those are fancy names for a model that maybe they do something. For example, random forest sort of model. That's a classification model. There's linear regression. There are time series. If you're dealing with time series data, there are time series models for that. So it really depends on your use case. Then what is the difference between data science and data analytics? Okay, Kelvin, let me go back to this life cycle and sort of explain to you my understanding of data analytics versus data science. So when we come from start, so every data science problem, regardless of whether it's an analytics or data science problem, I think up to and including here, so from start up to understanding the data and visualizing the data, I think that is where data analytics, you can say that is data analytics. You get the data, clean the data, look at the data, and present your results. But when we now go to, feature engineering, creating models, and predictive, that is where we enter the data science. I hope that answers your question. Okay. Oh yeah, I hope I've answered most of the questions. Are there any questions that anyone wants to ask on by unmuting themselves? Okay, great. Yeah, so if there are no other questions, so there's a question from George. As an accountant in the finance industry, proficient in advanced Excel for daily use, what certification would you recommend I start with? So I've seen most people in the finance industry, they do a lot of R, and also Python is important. But what I would say is a certification is good. You can start by PAL provides some training on introductory data, the data science ecosystem. You can enroll to PAL for your training. You can also do basic online courses. But what I would encourage is certifications are good and they're important. But I think having the skill is, you can have 10 certifications, but you're not able to defend the knowledge you gained from the certification with the skills that you got. So just pick any language, any programming language. You can do R, and after you're done with the basics, pick up on a project. Don't dwell too much on learning the don't dwell too much on learning without practicing on a project. Do you have partnership innovation or offer internship opportunities? I believe PAL Predictive Analytics Lab might have such opportunities. Considering the reusable nature of Sheila of models, what impact does that have on ML engineering roles, and what do ML engineers do? So this is a two-part question, and I will start with the first one. I feel like the reusable nature of models is actually a good thing, and I say this because, to answer your question, after we have done the, looking at this cycle here, Sheila, after we've done our acquisition, data understanding, feature engineering, most of the work after doing the model deployment is ML ops, which is monitoring models into production. Yeah. So I feel like if you have reusable model, you're able to even rely or be more confident in the data that they're producing. But I feel like as an ML engineer, your role should mostly be monitoring your model in production. And I say this because data science and everything, there's a bias all the time. And for example, if you're producing sensitive models that require to be used by massive population of people, I feel like your role should actually be you should invest more in monitoring your models in production to ensure that the way they were defined, they continue to predict data in an accurate way. So my opinion is it's a good way that models are reusable, and organizations should invest more in the ops part of machine learning models post deploying them into production. I hope I answered your question, Sheila. Nicole, does a person who studies data science course has the same familiarity with one who does a 3-month short course? Definitely no, because one has studied for longer, and that applies to any sort of thing you do. The one who has done it longer has more knowledge. However, you might do a 4-year degree in computer science, and come out of that degree without having any tangible skills. So I think the one who is favored, regardless of whether they have gone to a school, they have done a course, is someone who can showcase they have evidence of the skills they say they have. So it doesn't matter, even if you take no certification, but you have projects you have built and you can talk to them and you can defend your skill set as a data scientist, I think you stand a better chance, regardless of whether you have gone to any school or done any certification. As a media person in the film industry, what certification and license would you recommend to specify? You don't necessarily have to. The thing about data science, after you've gained your skills, after you have gained your math, your computer fundamental skills, the domain doesn't really matter. I don't think I've seen a course specific to become a data scientist in X industry, unless it's for advanced topics or very high level things about a domain knowledge in that area. So I would just suggest pick any course you want to do, right? You can check the Google Data Analytics certification, Predictive Analytics lab, this or institution. They offer training as well. And the good thing about such a training is like you're being taught by real people. You can ask questions, you can connect with people. Just start anywhere. I think people start overthinking, oh, where should I do, where should I start? But just really start anywhere, and as you start, don't necessarily start thinking, oh, where do I specialize in, what do I do? I think the way becomes clearer as you move along. Any other question? Okay, I hope I have answered all the questions, and if I haven't answered your question, please let me know. Yes. So if there are no more questions, thank you so much for making the time. I see so many of you. Thank you so much. I really appreciate. If you need to connect with me on LinkedIn, my name is this name on the chat here, and I'm happy to talk through anything. And I'm open to suggestions, challenges, and Predictive Analytics have left their number here. So feel free to reach out to them for training classes or any other questions you might have. And Joel, thank you so much for giving me the opportunity to talk to people and to interact with people. And my parting shot for today will be, please prioritize knowing things. Show, not tell. Thank you so much, and have a lovely evening, everyone, or morning or day, wherever you are. Thank you so much, guys.
Thank you very much, Teresia, for that, for delivering such an enlightening and an engaging session. Your expertise and passion for data science have made today's discussion both insightful and also practical. And I believe every one of us is living with a strong understanding of how data science can impact our work and different industries. Before we wrap up, I would like also to share that we have some upcoming opportunities for anyone that would want to maybe continue developing their skills in data and analytics. And also we have an intake for Power BI training that is starting on the 26th of this month. That is ideal for learning how to create impactful data visualization and also reports. And we also have an ongoing intake for the advanced Excel course, which is also offering powerful tools for data analysis and also productivity. And and also for the ones that would want to have a more comprehensive dive into the data space, our business intelligence and data science course is also intake is also going on. And if you're interested in any of these programs, don't hesitate to reach out. Thanks everyone for creating time to be in this place. We normally say in predictive analytics that the best investment that someone can make is investing in the knowledge, investing in yourself and upskilling. As we've been taught by Teresia, that any opportunity that you get, just advance the skills, because now with everything that is happening now, technology is changing, and we either upskill or we are left behind. And if we are left behind, we'll be replaced by other people that gains the skills ahead of us. So I would like to wish everyone a lovely evening. I think we've kept time, and in case you have a question and that it has not been answered, you can just reach to us. There's a number that I've shared in the chat box. So just reach out, and we are open to answering any question and also working with you through this journey of data science. We normally create a community. That's why you can see we are still in contact with Teresia, who was in cohort 1, and we are happy to and proud to have such a great person in our community. So thank you everyone once again, and I wish you a lovely evening. If you are not in Kenya, I wish you maybe a good morning wherever you are. Like Teresia said, I know there are some that are waking up now when others are going to sleep. So have a lovely evening, and we'll reach out and follow our social media platforms in Facebook. We are also in Twitter. We are also in LinkedIn, Predictive Analytics Lab, and we shall work together through this journey. Thank you very much, and have a lovely evening.
Thank you.